Welcome to the Deep Dive. Today, we're looking at something truly harrowing, the crash of Air India flight AI171.
Yeah, June 12, 2025. A flight from Ahmedabad to London.
Meant to be routine, carrying 242 people. But it crashed just moments after takeoff, a shocking, tragic event.
Absolutely gripped everyone.
And our mission today, well, it's to go beyond those initial headlines, beyond the shock.
Exactly. We need to unpack what we know.
We'll dive deep into, all the sources we have, eyewitness accounts, flight data, expert analysis, even historical context.
The goal is to give you, our listeners, a really clear, comprehensive picture.
Understand the complex factors at play and what this all means for air travel safety more broadly.
It's a crucial deep dive, this one. Touches on so many layers of safety, accountability, things that aren't always obvious right away.
That's a really important point.
Yeah.
So let's start maybe with the basics, the aircraft itself.
Right. It was a Boeing 787 Dreamliner, generally seen as a modern, pretty reliable plane.
But the story, it seems, actually starts even before takeoff. There was a passenger, Akash Vatsa.
Yes, he was on an earlier leg of that exact plane's journey.
Yeah.
Paris, Delhi, Ahmedabad.
And he noticed some things.
He did. Reported issues with the air conditioning, the entertainment system completely out, and he even mentioned seeing the wing flaps constantly moving.
Constantly moving. That sounds off.
It does. And these observations were just hours before the crash, which is striking.
Okay, so fast forward to the actual flight, AI171, there was a slight delay.
A slight delay, yes.
Yeah.
And the refueling took about 42 minutes.
Which is a bit
A
long.
bit longer than the usual 30, 35 minutes. Yeah.
But a DGCA official, that's the Directorate General of Civil Aviation, noted it wasn't necessarily out of the ordinary for a flight with maximum payload.
Right. And the crew, we need to talk about them.
Hugely experienced. Captain Simit Sabharwal, over 8,200 flight hours,
Wow.
and co-pilot Clive Kunder, even more, 10,100 hours. Immense experience in that cockpit.
So you have this modern plane, maybe a few quirks reported earlier, but a very experienced crew. Seems like things should have been okay. You'd think so. The plane started moving towards the runway around 1:31 p.m. Got takeoff clearance at 1:34 p.m.
All the pre-checks done.
All pre-check routines completed by 1:38.24 p.m. No warnings from the crew, no requests for changes. Weather was clear.
Okay, so takeoff from runway 23 at 1:38.44 p.m.
Exactly. But then, just seconds later, literally 11 seconds,
Yeah.
at 1:38.55 p.m.
What happened?
It only reached an altitude of 625 feet,
That's incredibly low.
dangerously low.
Yeah.
And then came that chilling call to air traffic control.
Thrust not achieved call.
Thrust not achieved, falling, and then nothing. Contact lost.
Just like that.
Just like that. The impact. It was catastrophic, only 34 seconds after lifting off,
Where did it crash?
but 1.5 kilometers from the airport.
Yeah.
It hit the BJ Medical College hostel in Mignani Nagar.
Oh, no. On the ground casualties, too?
Tragically, yes, it was lunchtime. Around 35 students were in the canteen when the plane hit.
That's just horrifying.
The chaos was immediate. Students talking about a sound like an earthquake, people jumping from windows, just
Yeah.
unimaginable scenes.
But amidst all that, there was one survivor from the plane.
Incredibly, yes. Vishwas Kumar Ramesh, a British citizen,
Where was he sitting?
seat 11A, near an emergency exit. His quick thinking, somehow, allowed him to escape the wreckage.
The only survivor from the plane.
The only one. The total death toll, including those on the ground, is estimated at over 270.
It's staggering. That single survivor story, it really underscores the violence and randomness of it all.
It really does. And highlights how crucial things like emergency exits are, even in the face of such forces.
So after the immediate shock and rescue efforts, the focus shifts, right, to the investigation.
Absolutely. The black boxes, the cockpit voice recorder, CVR, and the flight data recorder, FDR, they were recovered relatively quickly.
And these are key.
Absolutely vital. They record everything, cockpit sounds, conversations, altitude, airspeed, engine parameters.
Right.
It's the core data for understanding what went wrong.
Who's leading the investigation?
India's Aircraft Accident Investigation Bureau, the AAIB. But it's a collaborative effort. Teams from the UK and US are assisting. And the U.S. National Transportation Safety Board, the NTSB, is running a parallel investigation.
Why the NTSB?
Standard procedure when a U.S. manufactured aircraft is involved. It's a Boeing, after all.
Got it. There was some talk about sending the black boxes to the U.S.
There was initially, but India's aviation ministry clarified pretty quickly that the analysis would happen in India.
Okay. So besides the black boxes, what other evidence started coming out?
Well, there's flight radar data. That gives us very precise timings. The flight path
Mm.
helps build that exact timeline of the final moments.
Mm-hmm.
But then there's something else, a really critical piece of evidence,
Yeah.
a video
A video from who?
taken by a 17-year-old kid named Aryan. He was visiting Ahmedabad, first time there, and he was just filming the planes taking off to show his friends back home.
Just Vikings and casually.
Yeah, and he accidentally captured some really, really startling visual details of AI-171's takeoff. High-quality video, too.
Wow. What did it show? What was so startling?
Two major things really stand out. First, the landing gear. It was still down, extended after takeoff.
Is that normal?
Highly unusual. Retracting the gear is usually one of the very first things pilots do after getting airborne.
Mm-hmm.
Reduces drag.
Okay, so gear down. What was the second thing?
Even more significant, perhaps,
Huh?
the wing flaps. They were retracted, not deployed.
Retracted. Okay, I'm not an aviation expert. Can you explain what flaps do and why that's important during takeoff?
Sure. So flaps are these movable sections on the back edge of the wings.
Right.
When they're deployed, extended downwards and outwards, they increase the wing's surface area and change its shape, its curvature.
Okay.
This does two things. Generates more lift, which you absolutely need to get off the ground, especially at lower speeds.
Makes sense.
And it also creates more drag, which helps control speed for landing. But for takeoff, the main benefit is that increased lift.
So they should be deployed for takeoff.
Absolutely.
Yeah.
Maybe at a slightly different angle than for landing, but definitely deployed.
Yeah.
You only retract them fully once you're higher up, faster, and cleaning up the aircraft for the climb and cruise.
So seeing them retracted during takeoff in that video.
It raises a massive question. Why? Why weren't they in the correct position for takeoff? It points to something being seriously wrong.
Okay, that really sets the scene for the investigation. Now, naturally, after a crash like this, theories start flying around immediately. Pilot error often comes up first.
It does. And there were initial suggestions. Maybe the pilots panicked, forgot the landing gear, or maybe they mistakenly retracted the flaps instead of the gear.
But that didn't stick.
No, those theories met pretty strong pushback quickly. Aviation experts, even a senior Air India 787 pilot, weighed in.
What did they say?
They pointed out that modern planes like the Dreamliner have sophisticated warning systems, alarms, lights, specifically to tell pilots if the flaps aren't set right for takeoff or if the gear isn't up when it should be.
So, systems to prevent exactly those kinds of mistakes?
Precisely. And given the sheer experience level of Captain Sabarwal and co-pilot Kunder, we're talking nearly 20,000 hours combined. It seemed highly improbable they'd just ignore or miss those fundamental warnings.
Right. That makes sense.
Plus, another expert, Captain Sohail Handa, made the point that a Dreamliner is powerful. It could likely climb past 600 feet even on one engine, and potentially even without flaps deployed correctly, suggesting the problem was likely more severe than just incorrect configuration.
So, if it probably wasn't simple pilot error, what else could explain what happened? This is where that video evidence becomes even more critical, right?
Exactly. Deeper analysis of Aryan's video revealed something else. Evidence pointing towards a total loss of power.
Total power loss. How could they tell that from the video?
If you look very closely, frame by frame, you can see a small object deploying from underneath the aircraft's belly.
Okay. What was it?
Experts identified it as a ram air turbine, a RAT.
Oh, RAT, like the animal.
Yay, no. RAT, ram air turbine. It's basically a small windmill.
A windmill on a plane.
Yeah, it's a last resort safety device. It's tucked away. But if the plane loses all its main power sources, both engines, the auxiliary power unit, the RAT, automatically deploys into the airstream.
And what does it do?
The wind spins it, and it generates a small amount of emergency electrical and hydraulic power, just enough to keep the most critical flight controls and instruments working. Gives the pilots a fighting chance to control the plane, maybe glide to an emergency landing.
But there's a catch.
There is. It needs airflow, sufficient airspeed and altitude to spin effectively. And AI-171, tragically, in its very short flight, it just didn't have enough of either for the RAT to make a real difference.
Wow. So the RAT deploying suggests a massive power failure.
It strongly suggests it. And there's more evidence that seems to back this up.
Like what?
Remember the survivor, Vishwas Kumar Ramesh?
Yes. C-11A.
His account mentioned hearing a loud bang and seeing the lights flicker just before the crash. That's consistent with what might happen when an RNet deploys. The hatch blows open, that could be the bang, and the turbine starts drawing power, potentially causing a momentary flicker in any remaining systems.
That fits. Anything else?
There's also the sound. If you listen very closely to Aryan's video, amidst the other sounds, You can reportedly hear a distinct propeller-like noise,
Different from the normal jet engine sound.
very different from the typical sound of the 787's main engines. It strongly suggests the RAT was out and spinning.
Okay, so if there are not deployed, that tells us something catastrophic happened to the power systems. What could cause that?
Well, broadly speaking, there are three main emergency scenarios that trigger RAT deployment on a plane like this.
Right.
One, a total electrical system failure. Two, a total hydraulic system failure. Or three, dual engine failure, both engines losing power.
And where does the evidence seem to point in this case?
The signs are increasingly pointing towards that last one, dual engine failure.
Why? What supports that theory?
Go back to that final desperate call from the pilots.
Thrust not achieved.
Exactly. Thrust is the power from the engines pushing the plane forward. If thrust isn't achieved, that points directly to a major engine problem.
Okay.
And remember the landing gear being stuck down. Retracting the gear requires hydraulic power, which is primarily supplied by the engines, if the engines failed.
No power to pull the gear up, it connects.
It potentially connects, yes.
But dual engine failure.
Yeah.
You said that's incredibly rare.
Extremely rare. Something like only 7 documented cases globally in the last 70 years of jet aviation. It's almost unheard of for both engines to fail simultaneously.
So if that happened, the big question is WHY.
Precisely. And that leads to sort of 3 main sub-theories being investigated right now.
Okay, what's the first one?
Fuel contamination. This has gained quite a bit of traction.
Like bad fuel got put into the plane.
Essentially, yes.
Right.
S.J. Muralidhar, he's a former deputy director at India's National Aerospace Labs, suggested this. Contaminated fuel may be with water or sediment, microbes, even potentially diesel exhaust fluid getting mixed in by mistake.
Could that really cause engines to fail?
It absolutely could. It can lead to reduced thrust, erratic engine behavior, or even a complete flameout.
Has this happened before? With a Dreamliner?
There was a worrying incident in March 2019. A Boeing 787 in Japan suffered a dual-engine malfunction, suspected fuel contamination.
Wow.
Luckily, in that case, they managed to land safely.
So this theory puts the focus on the fuel suppliers at Ahmedabad airport.
It certainly raises serious questions about fuel quality control and testing procedures there, yes.
Okay, fuel contamination is theory 1. What's number 2?
Possibility number 2 is a total electrical failure affecting the engine controls.
How would that work?
A senior pilot explained this possibility. Modern engines are electronically controlled. They rely on systems fed by the plane's generators, specifically things called variable frequency starter generators, or VFSGs.
The plane's mini power plants, essentially.
Exactly. If these VFSGs failed, the electronic brain controlling the engines could lose power. The engines might still be physically capable of running, but the system telling them how much thrust to produce wouldn't be working.
Is there a backup?
There is the Auxiliary Power Unit, the APU. It's a smaller jet engine, usually in the tail, that provides backup power. But it's not instant.
How long does it take?
It can take up to 90 seconds to start up and deliver full power. In AI171. Well, it was only in the air for 34 seconds. Not nearly enough time.
So if the main generators failed and the APU couldn't start fast enough?
The engine controls go dark. No controlled thrust. Again, consistent with thrust not achieved.
Have there been electrical issues with Dreamliners before?
Yes. Back in 2013, there were those incidents with Japanese 787's battery failures leading to emergency landings. One had smoke in the cockpit. That actually led to the entire global fleet of 787s being grounded for a while.
And what caused those battery issues?
Ultimately traced back to manufacturing defects in lithium-ion batteries.
Okay. So fuel contamination, electrical failure. What's the third main theory?
The third angle is a mechanical error. This could be one of two things. Either a fundamental manufacturing defect.
Blaming Boeing?
Potentially, yes. Or it could be a maintenance failure.
Which would point towards?
Air India Engineering Services Limited. At the time of the crash, they were still a government entity responsible for maintaining most of Air India's 787 fleet.
Are there precedents for mechanical issues, either manufacturing or maintenance, on Dreamliners?
There have been disputes. In 2020, for example, Norwegian Airlines publicly accused Boeing of persistent engine problems with their Dreamliners, leading to flight diversions. They even ended up scrapping one 787 after only about 10 years in service because of these alleged issues.
So multiple potential paths leading to that possible dual engine failure, fuel, electrical, or mechanical.
Exactly. And the investigation will be painstakingly looking at all three.
This crash, though, It feels like it's doing more than just raising questions about this one flight. It's shining a pretty harsh spotlight on broader patterns, particularly concerning Boeing.
Unfortunately, yes. There's been a growing chorus of concern. We've heard from several whistleblowers, current and former Boeing employees,
Thank you.
people like engineer Sam Salapore, technician Joseph Clayton, quality manager John Barnett. They've made some really serious allegations.
About what?
Claims of, well, shoddy manufacturing practices, particularly at Boeing's plant in Charleston, South Carolina, where the 787s are assembled. Faulty parts being used, even finding metal debris left inside completed aircraft.
Debris inside the planes.
Yes, shavings, things left behind during assembly. And critically, they alleged that there was pressure on employees not to report these safety concerns. A culture of silencing dissent, perhaps.
That's deeply worrying.
And there's more. An Al Jazeera investigation claimed the FAA, the U.S. regulator, allowed Boeing to introduce new features on the Dreamliner, like those lithium-ion batteries we mentioned, without the really rigorous testing you might expect, despite the fact they later caused problems.
So questions about oversight, too.
Definitely. It raises questions about how closely regulators were watching.
And didn't one of those whistleblowers, John Barnett, make a chilling prediction?
He did, tragically. Burnett, who sadly passed away earlier this year, had previously stated that he believed manufacturing defects and negligence could take 10 or 12 years to manifest as a major accident.
And AI171.
Was 11 years old, delivered in January 2014. It fits right into that time frame he warned about.
There was also another quality manager, Cynthia Kitchens.
Yes, she raised concerns way back about 11 specific Dreamliners delivered between 2012 and 2013. She flagged them as problematic. 6 of those 11 went to Air India.
6 to Air India.
And she recounted this really disturbing comment from her boss when she voiced her worries. He apparently said something like, "Don't worry about it, they're all going overseas."
Overseas. As if safety standards are different depending on the destination.
It certainly implies a dismissive, perhaps even discriminatory attitude towards safety for non-U.S. airlines. And while the crashed plane AI171 wasn't one of those specific 11 being delivered just after in early 2014, it absolutely fuels concerns about the quality control culture at that time.
And all of this comes, of course, after Boeing's massive crisis with the 737 MX-us.
Exactly.
Yeah.
The 2 fatal crashes in 2018 and 2019, killing 346 people. That led to a huge $1.1 billion settlement and widespread accusations that Boeing had prioritized profits and speed to market over fundamental safety engineering.
It paints a troubling picture, but to be fair, lots of airlines fly Boeing planes without these kinds of disasters. Is it just Boeing, or are there other factors here? What about Air India itself?
That's a crucial point. While the focus is heavily on Boeing right now, especially given the potential manufacturing or design links, Air India has faced its own set of challenges, particularly since being taken over by the Tata Group.
Like what?
There have been reports and concerns raised about pilot fatigue. That was cited as a possible factor in the mass sick leave protest by Air India Express crew back in May 2024.
Okay.
And safety audits haven't always been glowing. A DGCA audit in July 2023 reportedly found issues within Air India's operations, mentioning fake reports and safety points that hadn't been properly audited.
Fake reports, that sounds serious.
It does. And then, just purely coincidentally perhaps, but still notable, the day before the AI171 crash, there was that incident on a London-Mumbai Air India flight.
What happened there?
5 passengers and 2 crew members became ill mid-flight. The suspicion was food poisoning from the onboard catering.
So, while not directly related to the mechanics of the AI171 crash, these incidents do add to a narrative of, well, ongoing operational and safety scrutiny surrounding the airline itself.
Exactly. It suggests multiple areas are under examination.
So, when you put it all together, the potential engine failure, the questions about fuel, electrics, mechanics, the troubling history with Boeing's manufacturing and oversight, and then the operational context at Air India, it really underscores that airplane crashes are almost never about just one single thing, are they?
Very rarely. It's almost always what investigators call a chain of events. Multiple layers of failure, multiple safeguards that somehow didn't work or were bypassed.
Right.
The complexity we're seeing emerge around AI171 fits that pattern perfectly.
What happens next in the investigation? When can we expect more concrete information?
While international civil aviation rules mandate a preliminary report within 30 days of a crash.
So that would be around mid-July 2025.
Roughly, yes. Around July 12th or so. That report should provide the first official findings based on the black box data and the initial wreckage analysis. It won't be the final word, but it should offer much more clarity in the primary causes.
Okay, so we'll be watching for that. This whole deep dive looking into AI171, it's just devastating on a human level, but it also forces some really big questions, doesn't it, about the systems we trust?
It absolutely does. We place enormous faith in these incredibly complex machines and the networks of people and processes that design, build, maintain, and operate them.
And this incident really highlights the critical need for constant vigilance, rigorous oversight, transparency, accountability, making sure safety is genuinely the top priority, not just words on paper. It leaves you thinking, doesn't it? What does a tragedy like this really tell us about those layers of responsibility? Are the safety standards we assume are universal truly applied everywhere with the same rigor? It makes you, the listener, consider how do we ensure that the advanced technologies we depend on every day are genuinely managed in a way that protects everyone, everywhere?